So you've probably seen on Facebook, I've had a bit of a project on. Specifically, I've been smashing the wall to pieces. But there is a purpose for this, which I'm about to reveal. And this isn't the sort of thing where I can just post a photo, because that rather misses the point of it. Because it's this thing. This thing is my landline now. And I'm just going to prove that by ringing my landline from my mobile. Now, it's kind of hard to illustrate this. So what I'm actually going to do here is I can see my phone. I'm going to put this on speakerphone. And what you'll hear is the echo back, just to prove it is actually working. Hello? Hello? Hopefully that's been picked up on camera. And sounds absolutely terrible. So I will turn that off again by hanging it up. What this actually is something called a 1948 design railway telephone. It's an omnibus phone. So these are kind of peculiar. What they used to work on is, rather than having a system where you have an exchange, what you do is you'd ring. So I'm not going to do it because this is actually would ring, and I'll explain that in a minute. But if you press this button here, you call out a series of pulses. And everyone else on that line will be listening for that set of pulses. If they heard their number, they pick the phone up. Really simple. Downside is you only ever had one phone conversation going at one time, but it works quite well. It was never, however, designed to work on the BT system. So I've had to have a bit of a play with this. If you don't like technical stuff, this is the point to hang up. But for those who are quite interested in the technicalities of this, I'll show you. So I've left this loose so I can get into it to show you what I've done. So this phone is a 1948 design. I don't actually know how old it is. Looking on, my guess is it's somewhere between 1950 and 1960, but I'm honestly not sure. The design itself is based on things that were done quite a while before that, and it's the BR version. What BR basically did is they said, well, all these railway companies have different designs, let's just have one standard design that works for everybody. And that's what this represents. So this is why it really does look quite old. You'll notice though, there is a few additions. Namely, we've got in here a couple of AA batteries, and that's just providing our power to this. So I have modified it. Basically, the problem I had was that this is quite novel. It works on, you've got two circuits effectively. You've got your ringer circuit, so your bell, and you've got the actual telephone circuit. The telephone circuit, when it's on the hook, and this is common to any phone, the telephone circuit's disconnected. The switch, which is just about in here, that will actually turn the telephone itself off. The bell is always connected. On this system, originally, you would apply 24 volts DC, and that would ring the bell. That apparently, I read literally about half an hour ago, it was standard across the board at the time, but that's long since fallen out of fashion. The system BT now use is an AC system. So rather than providing about 24 volts DC, it provides 48 volts AC. So that presented my first problem. So there's a little bit of modern wiring in here. If I point to it with a screwdriver, it's a beautiful thing. I'll get some close-up shots in a minute, but there's some wiring in here. If I bring that up, so you can see here, you've actually got a little rectifier circuit, and what that is doing is taking in the 48 volt AC and converting it to about 15 volt DC, and it's doing that through capacitive dropper effectively. So that's how that bit works. That's fairly simple. The rest of the wiring for that though is untouched, and when I was experimenting with it, even without that little circuit, it was working. The problem was though, I was giving it an awful lot of voltage, and frankly I probably would have burnt the thing out before awfully long. So that is a much happier system now. Other bits in here. So I said that was one half a circuit. Of course, the other half of the circuit. Oh, I should probably add that relay. That's what it is. That relay is to isolate the bell out. So all you do is when you ring, you're actually setting that relay off. And I can illustrate that quite nicely because the battery is the battery for the bell. So if I disconnect that, and I'm just going to get my phone out again. What we can actually do is if we just ring the phone, what you'll hear is the clicking sound of the relay working. I'm not sure if that's audible on it, but it is just audible to me. So what that's doing, that relay is effectively separating the bell out. That means then that can operate much lower power so that it's not draining on the battery of the thing supplying it. And it's just easier, it's a bit more reliable. And it doesn't matter what voltage you throw at it quite so much. So if I connect now this battery back on, this battery I fitted for obvious reasons. There was actually a 6-volt battery in this originally. It would have been a lead acid thing on the floor somewhere. For my purposes, AA battery suffices. But yeah, all this does is when you press it in, just rings the bell. Really simple. So yeah, that's your ringer circuit. The other half of this is the telephone itself, which is there obviously. Now, it took me an awfully long while to get my head around the wiring, which feels a bit shameful, really. What confused me is the fact there's actually 2 wiring diagrams in here. So you've got one up on this side, which I think is labelled figure 2, and the one down there, which is labelled figure 1. And they look similar, but quite different, and that really threw me for quite a while, until I had a brainwave and realised what's actually going on. Is this one down the bottom, they are the same, it's just this one down the bottom is actually showing you physically where the wires are jointed in and soldered in. Whereas this one is more schematic and just giving you an overview. And when I figured that out, it started to make a bit of sense. And it is actually really simple. It just uses an inductor, because the inductor serves a couple of purposes, but the primary one is it means you can't quite hear the microphone on the speaker. So it tries to stop you hearing your own voice so much. I don't think it works very well. It's probably a knackered inductor, I suspect. But anyway, yeah, so to feed that, the speaker of it actually is fed directly from BT. However, the only change I've had to make on this is it didn't really matter on this thing originally, because when you pick the phone up, you pick the phone up. The other person is just going to hear you connect. They don't need any confirmation. BT, however, require confirmation. And they do that by they basically detect a small DC flow. This phone, however, is not set up for that. It's designed to block the DC, so that the DC flows into a relay, leaving the AC just to flow into the speaker itself. So they've got a big capacitor on it. So the solution actually proved to be quite simple, which is just whack a big 1K resistor across the terminals. That allows BT to see a very small DC flow straight through. That then means they can detect that you've lifted the hook, because as I said before, this doesn't all switch on until you lift that hook. So that's how BT detect, okay, you've picked up the phone now, I'll stop trying to ring you. So yeah, it was a fairly simple solution. The only sort of complication with this thing is this little pair of AA's here. That's because the microphone has an amplifier in here, and it's a really simple amplifier. It literally just works off that same inductor I mentioned earlier, but it needs 3 volts to operate, and it's got to be an independent circuit because effectively it's running through a transformer, so it's got to be independent. So that 3 volts is provided by that. And yeah, the only other things in this really I've, for obvious reasons, fitted a couple of little fuses in just because I don't trust my own wiring. But other than that, that is a 1948 design telephone operating as a modern landline. And my guess is certainly in domestic properties, as opposed to ignoring heritage sites like heritage railways and things. It's almost certainly one of the oldest phones now in operation on the BT system, which I am rather proud of.